Depths of smooth scene points. We follow to estimate the depth at edges and texture followed by propagation of the results to other points. In our method, we use canny edge detector to decide whether a point is an edged or textured point. The depths of these points, called canny points, were then estimated from the blurring and deblurring approach. For convenience, we called the remaining points as the smooth points. The propagation algorithm to derive the depths of smooth points was based on the solution of the Dirichlet problem, which addresses the temperature distribution from the boundary to the interior of a medium. The solution of the Dirichlet problem is based on two principles, the maximum principle and the uniqueness principle. The maximum principle states that the interior temperature lies between the maximum boundary temperature and the minimum boundary temperature, and the uniqueness principle states that the solution of the problem is unique. In our approach, we regarded the temperature as the depth and defined the boundary points as the union of the smooth points at the border and the non-smooth points of an image. The depth was first assigned to the smooth points at the border of the image. Then, we used the solution of the Dirichlet problem to derive the depth of the smooth points inside the image. By this approach, the depths of the smooth points were never larger than those of the enclosing points. The steps of the depth propagation procedure are as follows. First, we normalize the depths of the canny points by setting the depth of the point farthest from the camera as 1. Then, we assign depths to the smooth points on the borders of the image. Because the top border of an image is usually the background, the depth of the smooth points on that border was assigned the value 1. For a smooth point on the left hand, right hand, and bottom borders, we assign the depth of the closest non-smooth point. Demonstrates an example how the depths are propagated to an image. An example of depth propagation to the interior smooth patches achieved by solving the Dirichlet problem. Top left, the depth map of non-smooth patches, the depth of patches farthest from the camera was set at 1, top right, the depth assigned to the border patches, and, bottom, the depth of the interior smooth patches derived by solving the Dirichlet problem.